चैंपियन कोर्स किन के लिए है? जो IIT JEE एडवांस का एग्जाम दे रहे हैं, मेंस का एग्जाम दे रहे हैं, उनके लिए है। ये कैसे ज्वाइन कर सकते हैं? आपको यूट्यूब चैनल पे जाना है, वहाँ पे ज्वाइन बटन है, मेंबरशिप लेना है यूट्यूब का। आप मेंबरशिप लोगे तो मैं इस कोर्स को ज्वाइन कर सकते हो। इसमें आपको पूरा कोर्स करवाया जाएगा, आपका लाइव डिस्कशन होगा, DP दी जाएगी, यानी पूरे ऑर्गेनिक केमिस्ट्री की कोर्स की गारंटी अच्छे से करवानी आपको सिखाने की मेरी होगी। तो आप ज्वाइन कर सकते हैं यूट्यूब के मेंबरशिप प्रोग्राम के थ्रू। ज्वाइन बटन पे क्लिक। हेलो, गुड इवनिंग ऑल ऑफ यू। Now let us solve a beautiful question before going to study cyclic conformer. Now which of the following has a zero dipole? This is a single choice question and you have to find out which of the following has zero dipole. Pause the video and then try your answer. Which of the following has zero dipole? From all the options, it seems that all are correct. If I check A option, the chlorine is more electronegative. This means the dipole will be on upper side. In this case, dipole will be on lower side. This means dipole is 0. Similarly, for this, dipole is 0. And third option is alkane. And since alkane is our non-polar, so all non-polar molecule has 0 dipole. And what about D? D, similar groups are there. It also seems that dipole of D is also 0. Now which one is correct? So I will tell you what is the correct answer. Then you have to find why. The correct answer is A. No, sorry, not A. Correct answer is C. C is correct answer. Now why A has dipole value, why B has dipole value, why D has dipole value? The option given is A is our staggered conformer. Since two chlorine are at 180 degree, this means it is a staggered conformer. If I draw another conformer of this 1,2-dichloroethane, it is our Gauge conformer. And this Gauge conformer has dipole value. Now since one of the conformer of 1,2-dichloroethane has dipole value, this means the whole one molecule has a dipole value. Now you have to use this formula. Overall dipole of this solution is mole fraction of staggered into dipole of staggered, mole fraction of eclipse into dipole of eclipse, mole fraction of Gauge into dipole of Gauge. This formula is applicable when the molecule undergoing conformational isomerism. If molecule is forming conformer, then we have to apply this. This means the overall dipole of particular that molecule doesn't depend upon the one conformer. It is a combination of all the conformer along with the mole fraction according to their stability. Now in this case, this conformer has 0 dipole. But if I draw another conformer, means if I draw Gauge conformer, Gauge has dipole value. If Gauge has dipole value, this means overall molecule has a dipole value. Similarly, in B option, we can draw conformer across carbon-oxygen bond. Since there is a single bond, there will be a rotation. And if we draw conformer across carbon-oxygen bond, now this will be the conformer. Now this conformer has dipole value, but another conformer has no dipole. This means overall this molecule has a dipole value. Now in this case, the dipole is decided by this conformer. Now we can explain D similar to example B. B and D are similar. In this case, the given conformer has dipole value. I can draw one more conformer of this. Now this conformer has 0 dipole, but another conformer has dipole value. This means overall molecule has dipole value. Now let us solve one advanced question was previously asked in 2000, probably in 2011 or 12. They asked that we have a 1,2-dichloroethane and the mole fraction of 1,2-dichloroethane, mole fraction of staggered conformer is 0.7 and dipole of Gauch is 5.5 dBi. Then what is the overall dipole of this 1,2-dichloroethane? Now we have to find the overall dipole of 1,2-dichloroethane, and the information given is mole fraction of staggered is 0.7 and dipole of Gauch is 5.5 dBi. Pause the video and try your answer. Now what is the answer? Now to solve this question, we require these data: mole fraction of staggered, dipole of staggered, mole fraction of eclipse, dipole of eclipse. Now first of all, which conformer is unstable? Eclipse is unstable. This means the mole fraction of eclipse can be neglected. In this case, mole fraction of eclipse is 0. The energy minima, the conformer which are at energy minima can be neglected. Energy maxima can be neglected. This means the mole fraction of eclipse is 0. This means this term is 0. Now similarly, the dipole of staggered conformer is 0. This means this term is also 0, because we know the dipole of staggered conformer is 0. Now in order to find out the overall dipole of the value, we require two things: first, mole fraction of staggered, and second, dipole mole fraction of Gauch, and second, dipole of Gauch. Since we know the dipole of Gauch is 5.5 dBi, then what is the mole fraction of Gauch conformer? This is the only unknown term which we have to find. Now since mole fraction of staggered is 0.7, this means the remaining mole fraction will be of Gauch conformer. This means the mole fraction of Gauch will be 0.3. Then what is the overall dipole? Overall dipole is 0.3 into 5.5 dBi. This will be the overall dipole of 1,2-dichloroethane. You got it? You have to neglect mole fraction of eclipse because eclipse conformer are unstable, and this term is 0. Mole fraction dipole of staggered, because dipole of staggered is 0. In that way, we can find out what is the exact value of 1,2-dichloroethane dipole value. Now, today we are going to study the cyclic conformer. Now, in previous lecture we studied how to draw conformer of open chain. In this lecture we will study how to draw cyclic conformer, how to determine their stability and different factors affecting flipping, etc. of cyclic conformer. Now, in order to study the cyclic conformer, first of all we should know what is the stability order. This is 3-member ring, this is 4-member ring, 5-member ring and 6-member ring. Now we have to determine which one is the most stable ring. Now hybridization of this carbon is sp3. This means the bond angle must be 109, but we know that bond angle is 60 degree. This means the cyclopropane has strain of 49 degree. Now what is the definition of strain? Strain means the deviation of angle from the original angle. For example, if we are expecting the angle must be 100 degree between two valencies, and if the angle is at 90 degree, this means there is a strain of 10 degree. Similarly, if the angle is 110 degree, again the strain will be 10 degree. In both cases the strain will be 10 degree. Then what is the definition of strain? Strain means the deviation from the actual hybridization or deviation from the actual angle. Got it? By this meaning we can find out strain of cyclopropane is 49 degree. Now in cyclobutane, hybridization is 109, but the angle is 90 degree. This means strain of 19 degree. Now in cyclopropane, the hybridization sp3 means 109 degree angle, but actual angle is 108. Now how I am calculating this angle? We can calculate this angle by n minus 2 into 180 by n. And what is the value of n? N means number of sides. In this case, n will be 5, n will be 4, n will be 3. Now, if I apply same formula in cyclopropane, the hybridization must be 109, but the angle is 120. We got strain of 11 degree. but it is the most stable ring. Now tell me why it is the most stable ring. Now, why this formula is not applicable on this? Because we are applying the formula on the rigid conformer. This one is our rigid conformer. Since cyclopropane will not exist in rigid conformer, cyclopropane exists in chair form. This is our chair form. And in this chair form, all angles are perfectly tetrahedral. This means that if angle is perfectly tetrahedral, angle is perfectly 109, so what is the strain? The strain will be 0 degree. So since cyclopropane exists in chair form, therefore it is a 0 degree strain. Now let me explain with the simple model. So first of all, write down in your notes, the relative stability order of ring is 6 member, 5 member, 4 member, 3 member. This is the order of stability of ring. Now this is our rigid conformer. Now this model represents this rigid form. This is our rigid form. Rigid form means all carbon will lie in same plane. This is our rigid form. If cyclopropane exists in this rigid form, then there will be a strain of 11 degree. Now, in order to minimize this strain, every molecule will try to be remain in lowest energy level. This means this cyclopropane will undergo buckling. The movement of this bond is known as buckling, and it will convert into chair form. This is the chair form. Now, what is the advantage of chair form? The advantage of chair form is all carbon are perfectly tetrahedral and the strain will be 0. So by buckling, the rigid form will convert into chair form. If you watch closely, you will see that this structure resembles with chair. Just like a chair, this is our sitting portion. We can keep a leg here. So this is our chair form. So first of all, write down that 6 member ring is the most stable ring. Now we will study how to draw chair form. What is the method to draw chair form? There is a very simple method to draw chair form. What we have to do? Now we have to draw chair conformer. What we have to do? First of all, draw two slanted parallel line. In order to draw chair form, you have to draw two slanted parallel line. Top end is connected by an V, in which LHS is greater than RHS, and bottom end is connected by inverted V, in which LHS is less than RHS. This means this side is A, B, C, D, E and F. Means A is parallel to D, B is parallel to E and C is parallel to F. Now draw the chair form. Draw two slanted parallel line. Top end is connected by V, LHS greater than RHS. Bottom end connected by inverted V, in which LHS is less than RHS. Just to practice, after drawing 4 to 5 chair form, you will be more comfortable in drawing further chair forms. Now, there will be a two type of bond in the chair form. Now, this is our chair form. There will be one axial bond. Axial bond is shown by vertical line and alternate up and down. Axial bond is shown by vertical line and alternate up and down. What is the meaning of up and down? First of all, you have to draw chair form. Then you have to draw axial bond here. First bond is up, second is down. First is up, second is down. Up, down. This means you have to draw up, next axial down, then up, down, up, and down. By this way, we can draw 6 axial bonds. Out of 6, 3 will be up and 3 will be down. Now let me explain again. This is our chair form. Now after drawing chair form, we have to draw axial bond. First is up, axial down, up, down, up, down. Now draw chair form in your notes and write that axial bond is shown on vertical line and alternate up and down. Now one more type of bond is there, which is known as equatorial bond. Now since carbon is sp3 hybridized, we have 2 valency. Suppose these 2 valencies are going inside the ring, they are forming the ring. Let us assume they are forming the ring. And the third valency is shown by axial bond, and we already explained that axial bond is shown by vertical line. Now what about the fourth valency? Fourth valency will be inside the ring or it will be outside the ring. If I draw fourth valency inside the ring, this will not be a perfectly tetrahedral. In order to be a tetrahedral shape, the fourth valency must be away from the ring. Means fourth valency means away from the ring. I explain you this fact because this is our 2 valencies are going inside the ring, third valency is axial, fourth valency must be away from the ring. Got it? Now, how to draw equatorial bond? It is very easy to draw equatorial bond. Whenever you have to draw equatorial bond, for example, we are drawing equatorial bond on first carbon. It must be parallel to the next carbon-carbon bond of the ring. Equatorial bond is parallel to the next carbon-carbon bond. If you are drawing equatorial bond on first, it must be parallel to second and third. If you are drawing equatorial bond this, it is parallel to the next carbon-carbon bond. Simply draw a chair form. For example, I want to draw equatorial bond in this carbon. This means it is away from the ring and parallel to the next carbon. Next carbon can be this, next carbon can be this, because they are already parallel. Equatorial bond is away from the ring and parallel to the next carbon-carbon bond of the ring. First of all, draw these 3 diagrams. After drawing 4 to 5 chair form, you will be comfortable to determine equatorial and axial bonds. Pause the video and try these examples. Now let us some more example regarding equatorial and axial. This is our chair form. This equatorial bond is parallel to this carbon-carbon bond. Similarly, this bond is parallel to the next carbon-carbon bond. This equatorial bond is parallel to the next carbon-carbon bond. This is parallel to the next carbon-carbon bond. In this example, draw chair conformer A for axial and E for equatorial. A at axial position and E at equatorial position. Similarly, you have to draw one more chair in which hydrogen at axial and hydrogen at equatorial. Hydrogen at axial and D as equatorial. And one more chair, hydrogen at equatorial, D at axial position. Now let us explain this example. In this example, the A represent axial, up, down, up, down, up, down. Okay? And E is equatorial, parallel to the next carbon-carbon bond. Got it? Now draw this cyclohexene. This is hydrogen. First it is easy to draw first axial bond. Axial up, down, up, down, up, and down. Then draw equatorial. This equatorial, 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 and equatorial. Now let us draw hydrogen at axial and D as equatorial. We have to draw hydrogen at axial and D as equatorial. So these are hydrogen at axial position. Then D must be at equatorial position. Equatorial, equatorial, equatorial. It is at equatorial position. Now, similarly, you can also draw where hydrogen must be at equatorial and D must be at axial position. Pause the video and write down all these examples. We can draw similarly for this example. First of all, you have to draw chair form. Now let us change the color. Hydrogen at equatorial and D at axial. This is our D, D, D. All D are at axial position. And hydrogen at equatorial. This is hydrogen, H, all hydrogen at equatorial position. Now, what is the meaning of these terms, axial and equatorial position, axial position? What is the meaning of the axial term, equatorial position? Basically, they are derived from the cyclohexane. Let us assume cyclohexane as a earth. If cyclohexane is a earth and if we pass an axis from its center, if we pass axis from center, then all axial bonds are parallel to that particular axis. Now, since these bonds are parallel to that axis, therefore they are known as axial positions. Similarly, the equatorial bond, since the equatorial bonds are parallel to this equator, therefore they are nomenclature as equatorial position. In that way, we are doing nomenclature equatorial and axial. Now, how to identify cis trans in disubstituted cyclohexane? This is the chair form of cyclohexane and this is the disubstituted. What is the meaning of disubstituted? 2 hydrogen is replaced by 2 another group. Now, you have to determine whether it is a cis conformer or whether it is a cis isomer or trans isomer. Now, what is your answer? It is very easy to determine cis and trans. What we have to do, we already know this carbon is sp3 hybridized. First of all, there will be a hydrogen which is at axial position. Now, this hydrogen is up. This means this chlorine will be down. Similarly, in this carbon, this chlorine is up and hydrogen is down. So, since one valence is down and one valence is up, this means it is a trans isomer. It is not a cis isomer. So, what you have to do, you have to determine simply that both valencies are on upper side, this means cis. If one of the valence is up and another on down, this means it is a trans. Now, using the same concept, what is the structure of, what is the type of configuration of this second isomer, whether it is a cis or whether it is a trans. Now in this carbon, chlorine is above, this means it is up, hydrogen is down. Similarly, this chlorine is up, hydrogen is down. Now both valencies are up, this means it is our cis. Got it? Now what is the answer of third? Whether it is a cis or trans. Now we have to use the same concept. This carbon, hydrogen is above the plane, this chlorine is below the plane. This means this chlorine is down. Now similarly, this hydrogen is down, chlorine is up. Now this is up and this is down. This means this isomer is our trans form. Simply you have to check which valency is up and which valency is down. Pause the video and write all these examples. Now let us solve one question based on this cis trans. This is our chair conformer and these are the numbering on the carbon. I am numbering all the carbon. E represent equatorial position and A represent axial. Now what you have to do, for example 1, 2 position. So we have to make a pair across first and second carbon. So first axial and second axial, if I form a pairing A and A, so what is the relation between A and A? A is up, A is down. It is a trans, so you have to write AA. Similarly, what is EE? EE up, down, it is a trans. If we consider A and E, AE means it is a cis. Again A up, E up and A down, it is also a cis. Cis means same side, this is E, A, down, down, cis, A, E, up, cis. Now similarly you have to form 4 pair across 1 and 3rd carbon and you have to determine which pair are cis and which pair are trans. And similarly you have to determine 4 pair across 1 and 4 and which pair represents cis and trans. In that way you have to fill this table. Pause the video and try your answer. Now what is the answer? In 1 and 3, axial up and axial up, both are up. This means it is a cis. Equatorial down, both are down, it is a EE. And then A up and E down, means it is a trans, AE and EA. What about 1 and 4? In 1 and 4, 1 is up, A up, E up. This means up is a trans, EA and AE. And what about if I consider A and A, up, down, it is a trans, AAEE is trans. In 1, 5, A up, AA will be cis. EE will be cis, AE will be trans and EA will be trans. In 1 and 6, 1A and 2E, E is our up. So AE is our cis, EA is our cis, AAEE. Now what about 2 and 3? 2 down and E down. Down means it is a cis form, AEEA. Now in 2nd and 3rd, E up and A up. Oh, we have to determine trans in 2nd and 3rd. So E is up and this E is down. This means both E will be trans, EE and AA. Got it? Now, whatever I taught you, let us explain with, let us learn with the help of this model. Now, first of all, this is our chair form. And as I already explained, that chair undergo buckling. Buckling means bond movement. And this will convert into this rigid to chair form. Now, two type of bond are there. One is axial and one is equatorial. This is our axial bond up. This is our axial bond down. Again, this is our axial bond up, and this is our axial bond down. The white represent axial, up, down, and down. Got it? Now we have to draw equatorial position. Now, how to draw equatorial position? The equatorial bond is parallel to the second carbon-carbon bond of the ring. So let me change the color. Now this color represents equatorial. If I have to draw equatorial bond across this carbon, this means the valency must be away from the ring. In order to be a tetrahedral, it must be, valency must be away from the ring. This means not inside the ring and parallel to the second carbon-carbon bond. If I draw equatorial bond here, this means the bond must be parallel to the next carbon-carbon bond. Now you can easily see that this equatorial bond is parallel to this carbon-carbon bond, or this equatorial bond is parallel to this carbon-carbon bond. Got it? Now similarly, if I draw equatorial bond in this position, it is parallel to the next carbon-carbon bond. This equatorial bond is parallel to the next carbon-carbon bond. In that way, you can draw all the equatorial bonds. Now, let me explain you cis and trans isomers. Now, this is our chair form. First of all, I am drawing the axial position. This is up, and next axial bond will be down. Now, if we are considering axial bond across first and second carbon, now we can clearly see that it is first valence is above the plane, second is below the plane, or they are up and down with respect to this carbon. This means it is a trans form. So whenever two valencies are adjacent to each other at axial bond, axial up, axial down, and it means 1 and 2 axial are trans to each other. We can also explain this by, or we can also understand this by equatorial position. If I draw equatorial bond on this carbon, this equatorial bond is down, axial up, equatorial down. For this carbon, this axial is down, equatorial is up. So this means if we will simply check two axial position, they are trans. If two valencies are trans, then remaining two also will be in trans. Either two equatorial, or either we can check two axial bond. In both cases, they are transformed. Got it? Now, that's all for today. In next lecture, we will learn how this ring is flipping and what are the effect in the stability. We will learn concept of stability, we will learn concept of flipping. And you can try the quiz after watching all these conformer lecture. First of all, we will complete all the conformer. In our JEE advanced syllabus, there are two type of conformers are there. Mainly it is a open chain, and there is no direct questions on cyclic conformer, but in understood to many reaction mechanism, we should have a knowledge of cyclic conformer. That's why we are learning the cyclic conformer in the detail. That's all for today. Thank you. Now let me explain cis-trans by 3D model. The chlorine represent up and down, means they are both axial position are trans to each other. Cl up, Cl down means trans. Now I will draw this transform in this model. Now you can easily watch that these color up and down are our transform. Or we can draw hydrogen, one hydrogen is up, one hydrogen is down. Now this is our transform. Got it? These two are trans, or two white are trans. Now I am drawing cis form. Now how I am interchanging chlorine and hydrogen. Now this is the model of simple cyclohexane. Now we are drawing up and down, means again we are drawing another transform. There are two different ways in which we can draw transform. Two chlorine are axial and two chlorine are equatorial. Now you can easily see that this chlorine is down and this chlorine is up. This means this is our transform. Got it? This is the actual model on left hand side, and how we draw is on right hand side. So there are two ways to draw trans. Both are at axial and both chlorine are at equatorial positions. Got it? उसको दिखाओ एक बार.